Welcome to Scholar Opportunity Nexus, and in today's series of video, we'll be looking at the sine rule. In our previous video, we spoke about the Pythagoras theorem, and we also said that apart from the Pythagoras theorem, we have other rules that we'll be looking at when considering vectors. We also said that the Pythagoras theorem explicitly used the right angle triangle. Aside this, it doesn't use any kind of triangle when representing it, but for the sine rule, it uses all the type of triangles that we have. That is the right angle triangle, the isosceles triangle, the equilateral triangle, and the scaling triangle. So let's get into this sine rule. So let's take just any type of triangle. We have to, let's say here is alpha, here is theta, and here is beta. And let's name the sides too as x, y, and z. Yes, and also the sine rule is known as the Lamis theorem. So anywhere if you don't hear sine rule, know that it's Lamis theorem. Anytime they say Lamis theorem, they are relating, but they are still saying it's sine rule. So for the sine rule states that the ratio of the angle of a triangle, one angle of the triangle. So the ratio of the sine of, let's take this, let's say alpha, to its opposite side. That's the side opposite to the angle, the side that's facing the angle, that's z, is a constant. Let me just write the constant. So the sine of an angle in a triangle, that's the interior angle in a triangle, to over its opposite side is a constant. That's for Lamis theorem. So since we know a constant, I mean a constant is just a number. It's just a number, meaning when you divide it, you get just a number, not anything that includes a variable. So since it's a constant, we can see that this and this, that's the sine of this angle to over its opposite side, that's the side facing it, would be, is a constant. So since it's a constant, then it can also be equal to the sine of this angle over the side facing it, and it can also be equal to the sine of this angle over the side facing it. So okay, let me just write it here. So let's take all of them one by one. Sine alpha over the side facing it, that's the side opposite to it, z, is equal to sine theta over x, and is also equal to sine of beta all on y. So this is mainly what we'll be looking at in a sine rule, or when they say a sine rule, this is mainly what they are talking about. So always know that the sine of the angle of an interior angle in the triangle over its opposite side is always a constant, meaning it's always a number. So in case maybe one angle is missing, you have its opposite side, you have another angle in its opposite side, you can see that you'll be able to find this angle using this Lamis theorem. And it's one of the very, very important theorems in physics and mathematics, and it will take you like, it's a very significant or fundamental theorem. You really have to know how to deal with it. Anytime you are being asked maybe to find the angle of a triangle, in a triangle, an interior angle, one side is given, another angle is given and its opposite side is given, you can surely use the sine rule to find this. And also know that, as I said earlier, it's unlimited, meaning you can use it for every kind of triangle, from the right angle triangle to the equilateral triangle to the scaling triangle and the isosceles triangle. It's not limited to any triangle, as we saw in the Pythagoras theorem and how to use it with SOHCAHTOA. This will be it for today's lesson. Thank you very much for staying up with us.